Assume you are analyzing the results of an experiment in which the participant had to complete the same task 5 times, and you are going to analyze how their completion times may have changed with the repeated attempts to perform the same task. One option for storing the results would be to hold them in 5 different variables, each containing a real number representing the number of seconds it took to complete the task. While this is an option, manipulating the individual variables will create overly long and complex code, since it involves handling a different variable name for each value. The size and complexity of the code will also increase significantly if the number of data values increases. Holding values in individual variables also lacks organization and does not reflect the commonality of the data or any potential ordering that may exist between the data values. To address the issues of storing and organizing multiple related pieces of data, programming languages provide variables that can hold sequences of information. These sequential memory models group all of the values under a single variable name and group the data into an organized sequence of elements, where each element holds a data value and each element can be treated like any other variable that holds that type of value. So if the data values in a sequence were all integers, each element could be manipulated like any other integer variable. So, returning to our earlier example, rather than storing our task completion times in 5 different variables, we could store them in a sequence variable named task time, where each element now holds one of the completion times. The length of a sequence is determined by the number of elements it can hold, so in the case of task time, it would have a length of 5. In order to allow the individual elements to be referred to in the program, it is common for the locations of the elements to be numbered in sequence. For example, the numbering could start with 1 and continue through the number of elements in the list. Each location value is referred to as an index. Indexing allows individual elements to be referred to by combining the name of the sequence variable and an index indicating its location in the structure. In programming languages, the index is often enclosed in square brackets. Remember that each element can be used like any other variable of its type. For example, if we wanted to output the value at the location indexed by 3, we could use a statement like print, task time, opening square bracket, 3, closing square bracket. This statement will output the contents of the location in task time that is indexed by 3, which is 58.8. Or if we wanted to increase the value in the last location by 1.5, we could use the statement task time indexed by 5 is assigned, task time indexed by 5, plus 1.5. This statement would use the value in the location in task time indexed by 5, which is 57.2, and add 1.5 to it for a total of 58.7, which would then be assigned to the location in task time indexed by 5. Not only do sequential models allow related data to be grouped together to reflect commonality, but they can also be used to reflect an intrinsic ordering to the data. In this example, the ordering of the values in task time also reflects the ordering of the data by successive test results for a participant. So, for example, if we wanted to derive the difference in performance between a given test and its predecessor, we can leverage the fact that the order of the information in the structure also reflects the test result order. For example, assume a variable test num holds the index of the test we want to compare to its predecessor. The difference in completion speeds could be calculated by the statement time difference is assigned task time indexed by test num minus task time indexed by test num minus 1. If we want to calculate the difference in the participant's performance between the second attempt to complete the task and the first, test num would hold the value 2. The calculation would then give us task time indexed by 2, which is 59.0, minus task time indexed by test num minus 1, or 1, which is the value 68.7. The result, negative 9.7, would be assigned to time difference, indicating an improvement in test completion times between the successive tests of 9.7 seconds. This same equation can be used to test the change in completion time between any successive tests by simply changing the value in test num, demonstrating one way in which the natural ordering provided by sequential models can be leveraged when analyzing data. Typically, a sequence of values is represented by a comma-separated list that is surrounded by a delimiter such as square brackets or parenthesis. For example, in Python, to assign the list variable first quarter the values January, February, and March, the comma-separated list of values would appear between square brackets. In R, the comma-separated list would appear between parentheses, preceded by the letter C, to indicate the values should be combined to form a vector. Both statements will result in the variable first quarter holding the sequence of string values January, February, and March. Check out the ways to specify a sequence of values in your programming language, including shortcuts.
Sequential models can be referred to by a variety of names, including lists, arrays, and vectors. They all have the characteristic of being a group of elements that are sequentially ordered and whose length is defined by the number of elements, or locations, that can hold data. However, specific types of sequences can vary in their implementation. For example, in an R vector, the index of the first element is 1, and the index of the last element is the number of elements in the list. In other languages, like Python and Java, the index of the first element of a list is 0, and the index of the last element is the number of elements in the list, -1. Certain sequential structures can grow larger by adding elements, or shrink smaller by removing elements. For other structures, once they are created to hold a certain number of elements, that number of elements, and therefore the size of the structure, cannot change. Check out the variety of sequential structures available in your programming language. A common error that occurs when using sequential structures is trying to access a location that does not exist by using an index that is less than the lowest index, or greater than the highest index in the structure. This type of error, often referred to as an index out of bounds error, will crash your program. Consider our previous example of determining the difference in task completion times between two successive tests. Assume we assign test num the value 1. The calculation of time difference would first access task time indexed by 1, giving the value 68.7. But when index test num-1 is calculated, it results in an index of 0, which is lower than 1, the lowest index in task time, causing an index out of bounds error. Likewise, if we assign test num the value 6, attempting to access task time indexed by 6 would exceed the highest index of 5, causing an index out of bounds error. Be particularly careful to remember the index numbering scheme used by your language. In schemes that begin their index numbering with 0, it is especially common to try to access past the end of the list, because the last element is at the location indexed by the list length -1, not the list length.
Recall that when a program is executing, the symbol table maintains the information about the program's variables and the values they contain. For variables that are base types, such as integers, reals, and even strings, the symbol table contains the value of the variable. For example, if we had a statement participant code is assigned W267H, the value W267H would be held as participant code's value in the symbol table. However, sequence structures contain multiple values, and those values are not held in the symbol table itself. Instead, the symbol table holds a reference to the first element of the structure, which is the value of the address in memory where the first element is stored. Since that value is a memory address, the location of the variable's values is represented visually as an arrow, pointing to the first element of the structure.
Recall that the variable type string allows sequences of characters to be stored in a variable. For example, a string variable first name can be assigned the value Lee. Although the value of a string variable is held directly in the symbol table, in actuality, strings are a special case of sequential structures. Each character in a string is an element of the structure and can be referred to by the index of its location. However, strings have a special property. They are immutable, meaning that the value of an individual element cannot be changed directly. So although an individual element of a string can be used, such as in an output statement, it cannot be changed with an assignment statement. For example, the last letter of first name cannot be directly accessed and changed to an A. However, since an assignment statement can be used to assign a completely new value to a string variable, First name could simply be assigned the new value, Leah, to achieve the same outcome. Be sure to check out the variety of operators and functions your programming language provides for manipulating strings.
Let's review the key points. Sequential memory models allow multiple values to be referred to by a single variable name. A sequential structure's length is determined by the number of elements in the structure. The elements in the structure are ordered and are sequentially numbered with index values that are used to refer to a specific element in the structure. Take care not to use index values that are out of bounds, that is less than the lowest index or greater than the highest index, as it will crash your program. The elements of the structure can generally be used like any other variable of their type. The symbol table holds the address of the first element of a sequential structure, not the values of the elements themselves. Strings are sequential structures, and the individual characters of the string can be accessed with an index. However, remember that strings are immutable, so while the individual elements can be accessed and used, they cannot be changed using indexing.